Okay, it's Mr. Masroni back to continue the review. Page 59, we're going to start with number 13, go right to 14 and 15, all right? In triangle BAT and triangle CRE, angle A is congruent to angle R. I already drew these triangles out, so I'm just going to mark them up. And BA is congruent to CR. Write one additional statement that could be used to prove that the two triangles are congruent. State the method that would be used to prove that the triangles are congruent. Now, it says one additional statement, so you only need one, but there are multiple answers here, okay? One thing you could first start with, you've got side angle. Now, with side and angle, we can do side, angle, side. And in order to do that, we have to show that AT is congruent to RE. That's one potential answer. All right. Now we can also do angle, side, angle. Okay. When you have a side and an angle and a side next to each other, you can go the other direction, use the angle, which would mean angle B would have to be congruent to angle C. Okay, and then the last one you can use is angle, angle, side. And that's going to give us angle, angle, side. So we have to use E and T. Angle T is congruent to angle E. You only need one of those, but there's three different ways you can do that. So there are multiple answers to a lot of these. Just want to point them out to you. On to 14. Given BE and AD intersect at point C. BC is congruent to EC, and AC is congruent to DC. AB and DE are also drawn, and we want to prove triangle ABC is congruent to triangle DEC. All right, we've got the sides. Can we get the angle in between? Yes, we can, because we know these are vertical angles. So this is actually pretty straightforward. I've put the given in here already. And then we're going to come right to, what I did was label them angle 1 and angle 2 to make this a little easier for you. Angle 1 is congruent to angle 2. And you would say vertical angles are congruent. All right, and that gives you everything you need. This is going to be a short, quick proof. Triangle ABC is congruent to triangle DEC, and that is, mix that up. I do that a lot. Side, angle, side. Make sure you get everything right there. Got everything numbered properly, everything lined up properly. We're all set. Okay, now for the bottom one. In the diagram of triangle MAH below, MH is congruent to AH. So these full sides are congruent. And medians AB and MT are drawn. Prove angle MBA is congruent to angle ATM. Now what I tried to do here was break up the two triangles, okay, just to show you how this is going to look. All right, this is where they are. We can see that these are the same, so that's going to end up being a reflexive property we're going to use. I'm also looking at the full triangle. If these are the same, that makes it an isosceles triangle. So these angles are the same. So this angle here and this angle here, if you do it separately. So what I'm going to do is I'm going to put that right in here. MA is congruent to MA, and that is the reflexive property. Okay, so we have that. And then what I'm also going to do is give those angles. And the angles are in the big picture. You have to make sure you use that one. I broke it up, but when you're describing in your proof, make sure you use the proper angles. HMA is congruent to angle MAH, and that is in a triangle, angles opposite of congruent sides, angles opposite of congruent sides are congruent. Okay? It's an isosceles triangle, and those are your base angles. You don't have to say that. You're adding steps. You can say it's an isosceles triangle and then talk about the base angles in an isosceles triangle, but you don't have to. You can go right to this step. In a triangle, angles opposite of congruent sides are congruent. All right, now we're going to work on the other side here. We've got angle, side, angle, side. We're not going to go with the other angle. We're going to try this side here, AT and MB, and that's going to have to do with the midpoints and the medians, okay? So what I'm going to do is I'm going to say B is the midpoint of MH and T is the midpoint of AT. Oh, 4. And it says a median is drawn to, slide this over a little, the midpoint of the opposite side. Okay, that's what a median does. It goes from the vertex, basically that angle, to the midpoint of the opposite side. So now, we can now say, because we have a midpoint, MB is congruent to BH, and AT is congruent to HT. A midpoint divides a segment into two congruent segments. Okay? Now, we can take all of those and put them all together. MB is congruent to BH, which is congruent to AT, which is congruent to HT. And what allows us to say that is when two congruent segments are cut in half by a midpoint, the four resulting segments are congruent. Okay, and I'm getting a little tight here with space, but you've got two equal sides, both cut in half, so all four pieces are congruent. Okay, now from there, we can say that our triangles are congruent. BMA is congruent to triangle TMA, and we use side angle side for that. And once we have congruent triangles, we have corresponding parts. Angle MBA is congruent to angle ATM. Corresponding parts of congruent triangles are congruent. And that wraps up page 59 of the review. Hope everything's going well. Thanks and good luck.